Hello everyone, welcome back to the channel. Today we are going to understand a very important concept in graph theory used in data structures and algorithms, Eulerian and non-Eulerian graph. Let's start with a simple idea. Imagine you are working along the edges of a graph and your goal is to use every edge exactly once at a time. If this is possible, the graph has a special property related to Euler. So, what is an Euler graph? A graph is called Eulerian if it contains an Euler circuit. An Euler circuit is a path that has start at the vertex, ends at the same vertex, visit every edge exactly once. As for the condition for an Eulerian graph, the graph must be connected. Every vertex must have an even edge. So let's move to an example for an Eulerian graph. Consider a square. It has 4 vertices. Each vertex has degree 2. Since all the vertices have degrees, even degrees, the graph is connected. You can start at any vertex, travel to all edges once, and return to the straight point. This is an Eulerian graph. So, this example shows an Eulerian graph from point A to B, B to C, and C to D, and travels to D to A. Every vertex has even number, degree number. Degree A has 2 and B 2, C also have 2 and D also have 2 points. As for Eulerian path, let's see A to B, B to C, and here B to D. So take A has 1, it means odd, and take B have 3 path, A to B, B to C, B to D, and take C have 1, B to C. This is not a Eulerian circuit. It has Eulerian path. As for a valid Eulerian path, we can take point A to B and B to C. Take K has 1, it also odd, and B has 2, it is even, and take C also have 1, it means odd. This also have Eulerian path, not a Eulerian circuit. So that is called Semi-Eulerian graph. Now what if we can use every edge exactly once, but we start and end at the different vertices? This graph called Semi-Eulerian. Condition: the graph must be connected. Exactly 2 vertices have odd degree. All other vertices have even degrees. This creates an Euler path, not a circuit. There is called non-Eulerian graph. A graph is non-Eulerian if it doesn't have an Euler circuit or an Euler path. This happens when the graph is disconnected or more than two vertices have a degree. Let's move to an example for non-Eulerian graph. Consider a graph with three or more vertices have or degrees. No matter where you start, you can't traverse every edge exactly once. So this graph is non-Eulerian. So let's see an example for non-Eulerian graph. Let's draw A, B, C, D. From A to B, B to D. And there's no path to traverse to the point C. So this diagram is non-Eulerian. There's no more than two odd-degree vertices, no Eulerian path or circuit, and this is a non-Eulerian graph. Let's quickly recap what we learned earlier. Eulerian graph is a connected graph and all vertices have even degree. Semi-Eulerian graph, connected graph, exactly 2 degree vertices. Non-Eulerian graph is a disconnected graph or more than 2 odd degree vertices. Why is this important in DSA? Eulerian graphs are used in network routing, circuit design, path planning problems, and puzzle and game algorithms. Understanding these concepts helps building strong foundation in graph algorithms. So that's all for today's video. If this explanation helped you, don't forget to like, subscribe and share. See you in the next DSA lesson.